Now this one is interesting. We can do it similarly as we did another problem that I've made a video for there, but this X here tends to drive students a little crazy, but we're going to use the same idea using the same structure as we did in the previous problem and show you that it works out really nicely. Now this particular action that we're going to be doing here is exceptionally useful in Calculus 2, and I wish my Calculus 2 students had learned this. So let's take a look at this problem. We're going to do something very similar. We're going to let cosine inverse of x over 5 to equal to theta, because we know again that the output of any inverse trig is going to be an angle. Now if that's true, then we can say that the cosine of theta is equal to x over 5. That's based on the idea of inverse functions and inverse trig functions. Now if it's true that the cosine theta equals x over 5, I'm going to use SOHCAHTOA and build a triangle. And I'm going to use the CAH part, where if this is my angle theta in a right triangle, cosine of theta is supposed to be adjacent over hypotenuse. And then I need to find this third side, and we'll call it A. So I know by the Pythagorean theorem that a squared plus x squared equals 5 squared. A squared equals 25 minus x squared. A is equal to plus or minus square root of 25 minus x squared, and this cannot be simplified because they're connected by a subtraction symbol. But I'm going to choose the positive version because A is a length. So I know this third side can be rewritten as a square root of 25 minus x squared. Now over here, cosine inverse of x over 5 we said was theta, so I can rewrite this as sine of theta. And using the triangle that I just built over there, just filled in all the sides, this is x, 5, square root of 25 minus x squared. So now, if I want the sine of the same theta, this theta, this theta, this theta, they're all the same theta. Theta, all the same. So that means when I'm referring to it here, it's the same theta in this triangle. So using SOHCAHTOA again, but the SOH part, I can say that sine of theta is the square root of 25 minus x squared divided by 5. So in the end, I can simplify the sine of the cosine inverse of x over 5 to be something that doesn't have a trig function in it at all, which is pretty miraculous. I think that's pretty cool. Square root of 25 minus x squared over 5. Now, a lot of students are asking, what does this mean? Well, that's just kind of giving you the domain for x. So in other words, the only x values that are going to work here is going to be x going from minus 5 to 5. It just restricts the domain for you so the problem works.